So one of the special cases we have when we factor is when we have the difference of two perfect squared. So something that is a perfect square subtracts something else that is a perfect square. And it will always factor like this. So if you look at something like x squared minus 81, okay. For one thing, it does not have an x term. It just has an x squared and then subtracting some other number. Okay. So that should flag to you that it is a little bit different than what we were talking about. Also, x squared is a perfect square, as is 81. So if you see something like this, you should hopefully, by the time we're done practicing all this, recognize that this is the difference of two perfect squares. Okay. If you don't, we can still factor this the way we talked about yesterday. Our number is 81 that we need to multiply to, and we want to add, because there are 0 x's in this problem, we would add to 0. So things that multiply to 81 are 1 and 81, 9 and 9, 3 and 27. But the ones that are going to add to 0 are -9 and +9. So we know this has to factor into x minus 9 and x plus 9 in order for that to be a 0x in the middle. Also, x squared is a perfect square, 81 is a perfect square. When we subtract them, it will always factor into the square root of the first thing, which is x, minus or plus, doesn't matter what order you do it in, the square root of the second thing. So square root of 81 is 9. So I know I have to have an x in the front and 9's in the back, one positive, one negative. So if we look at a problem like problem B, 25x squared minus 49. 25 is special because it is a perfect square. X squared is also a perfect square. 49 is also a perfect square. So perfect square subtracts perfect square is going to always factor into the square root of the first thing. What's the square root of 25? And the square root of x squared is x. So we have a 5x and a 5x. What's the square root of 49? So we have a 7 and a 7, and one of them is positive and one of them is negative, and it doesn't matter which one is first, whether it is a positive first or a negative first. Does not matter. So if you see something squared minus a number, chances are it is the difference of two perfect squares. Square root of the first, square root of the second, one's positive, one's negative. Okay? So when we are factoring a quadratic trinomial, when the number in front is not positive or -1, the first thing that you want to look at is, can we take out a greatest common factor? So like in A, could we just take out a 2? Is everything just divisible by 2? Could we do that and then factor it? Okay. Now, it is not all divisible by 2. Okay. So we can't just factor out a 2 and then deal with it the way we did yesterday. We have to deal with it differently. Now, one option, don't write this down, okay? One option is to start like we did yesterday, putting in our parentheses, okay? But instead of having just an x squared, we have to have these first two things multiply to 2x squared. So one of them would have to be a 2 and one of them would have to be a 1. Okay? And we know that we'd need numbers that multiply to 12. So we could use 2 and 6 or 3 and 4 or 1 and 12. But what gets complicated is, remember, we would have to FOIL this back out and get back to where we were. So one of these numbers, when we are adding these back together, is going to get multiplied by 2. Okay, so I've done this enough times that I can figure out that this should be a 4 and this should be a 3. That would multiply to 12. And when I FOILed it back out, I would get an 8x and a 3x from my outers and my inners that would add to 11. Okay, so it is possible to factor it, just kind of guessing and checking. That is not my recommended method. Okay, my recommended method is to do it like this. We're not even going to start with parentheses yet. Okay. Our first step is to multiply A times C. So the first number times the last number. When you take the first number times the last number, then what we're going to do is find the numbers. But in this case, we want two numbers that multiply to 24 and add to 11. Okay. So instead of finding two numbers that multiply to 12, we're looking for two numbers that multiply to 24 and add to 11. So factors of 24, I could do 1 and 24, 2 and 12, 3 and 8, 4 and 6. Because I have a positive 12, positive 2 out front, positive 12, positive 11, everything's going to be positive. So 1 and 24 would give me 25, 2 and 12 is 14, 3 and 8 is 11, 4 and 6 is 10. So 3 and 8 is what we want. Okay. So 3 and 8 are our numbers that we want to use. Now, instead of using parentheses right now, okay, what we're going to do is rewrite our original equation, or our original expression. Okay. So I'm going to rewrite it as 2x squared. And I'm going to change the 11x, instead of writing it as 11x, I'm going to write it as 8x plus 3x. So instead of writing it as the 11x that it was originally given to us, I'm going to rewrite it using 8x plus 3x. Okay. And that order does matter. Okay. I didn't want to put a 3x right here because what I'm going to do is break this into two pieces. I'm going to try to factor the first two pieces together, and I'm going to try to factor the second two pieces together. So my 2 and whatever number I put here need to be divisible by the same thing. So I'm going to break this into this piece and this piece. Now, if you don't end up where we're going to end up, you might just have to switch the order of those 8 and 3. Okay. So if I look at 2x squared plus 8x, both of them are divisible by 2, and both of them have an x. So I can take out a 2x. If I take out a 2 and an x out of 2x squared, I'll be left with x. If I take it out of x, 8x, 8 divided by 2 is 4, and I took the x, so I'm left with x plus 4. Then I'm going to factor the second piece. So 3x plus 12. 3x plus 12, they are both divisible by 3. If I take out a 3 from 3x, I'm left with x. 12 divided by 3 is 4. So what happened when we factored it like this as two separate pieces? Both of them have an x plus 4. So because they both have something in common, we can factor it again. They both have an x plus 4, so we can take that out. If we take the x plus 4 out of the first term, what are we left with? If we take this x plus 4 out, what are we left with? 2x. And if we take the x plus 4 out of the second term, what do we have? 3. So I have an x plus 4, and I have a 2x plus 3. And now it's factored. So if we look at B, first step was to multiply 4 times negative 3, we get negative 12. So we're multiplying the negative 12, adding the negative 4. So my options are 1 and 12, 2 and 6, 3 and 4. And which one of those has a difference of 4? 2 and 6. So do we want the 2 to be positive or the 6 to be positive to end up with a negative 4? Because the 4 is negative, we want the larger of 2 or 6 to be negative. So we're going to use 2 and negative 6. But again, we're not just setting up our parentheses and putting things in, we have to rewrite. So we have 4x squared and then a minus 3 at the end. So do you think I want to put plus 2x here or minus 6x here? Do I want to put the 2 here and the 6 here, or the 6 here and the 2 here? So we try to figure out what order those x's need to go in, and now I'm going to factor the first grouping and then factor the second grouping.